continue our chapter 9. If you remember last class, we do the row operation, and you want to have 1 at the diagonal, 0 underneath, and on the above the diagonal it can be anything. So if you have something like this, you will substitute it back and you will have one solution. If you solve it, this is called row echelon form, which means you have 1 at the diagonal. If you solve it and you come across the last row or any row that you have 0 equal to 0, which is a true statement. So in this case, you're gonna stop and say infinitely many solutions, which means the three-dimensional is either on the same plane or it crossed and become a lie. The last case here, if you solve and get the row echelon form, that 0, 0 on the left hand side and some constant on the right hand side, which is false statement, 0 not equal to 3, then you're going to conclude that there is no solution. Now let's look at a matrix. I did n by n here. It's a square matrix. So the first cell, you're gonna have A11, which means first row, first column. This cell is for A12, which is mean first row, second column. All the way to the last one, which is mean first row, n column. Same thing here, you're going to have second row A21, second row, first column, and so on. So this is n by n. And if I asked you find A23, so you know is second row, third column. All right. Now matrix algebra. So matrix algebra, all the distributive property, associative property, and all that is whole. The only one that's not whole is multiplication. It's not commutative. It means if you have A times B, it may not equal to B times A. A lot of times it's not equal. So let's look at our example here. I have a matrix A 2 by 2. Matrix B also 2 by 2. So let's say I can multiply a constant to a matrix. So basically I multiply 2 to every cell in matrix A. So 2 times 1 is just 2, and then 2 times 2 is 4, 6, 8. All right. If you multiply constant to a matrix, you just multiply constant to every cell on the matrix. Now you can add too. If you add a matrix, they have to have the same dimension. A is 2 by 2, B is also 2 by 2, and 2A is still 2 by 2. So I can add them. So basically you add each cell to A11 to A11, A12 to A12, and so on. So 2A, this is the first cell A11, so I'm going to add to B. So 2 and negative 1 is 1. 4 and 0 is 4. 6 and 2 is 8. 8 and negative 3 is 5. All right, very straightforward. Now multiplication. If I have matrix A, the dimension, it doesn't have to be a square matrix. Let's say matrix A, the dimension is M by P, and matrix B is P by N. So the number of column of matrix A has to be the same as the number of row of matrix B in order for them to multiply each other. And the product of it will be M times N. So it's going to have N row, M row, and N column. Right? So let's look at the first example here. I have a matrix A. The matrix A is 2 row, 1, 2, 2 row, and 3 column, 1, 2, and 3. Matrix B, I have 3 row, 1, 2, 3, and 2 column, 1, 2. So the number of column of matrix A is the same as the number of row in matrix B, so you can multiply them. And the product will have dimension of 2 by 2. So you're going to have something look like this. 2 by 2, A11, A12, A21, and A22. So let's see how would we multiply a matrix. So the first cell here is A11. So you're going to multiply the first row of A to the first column of B. Alright? A11, first row of A, first column of B. So let's do that. So I'm going to multiply each cell. See, I have 3 sets, 1, 2, 3, 1, 2, 3. So I'm going to multiply 2 times 1. I'm just going to write it out here. 2 times 1 plus the next one going to be -1 times -2. Plus the next one going to be 0 times 4. So this is going to be your A11, right? So let's do that. What do I have? I'm going to have 2 plus 2 plus 0, which is 4. So your A11 will be 4, right? So let's try the next one. It's going to be first row, A12, first row but second column. So I'm going to use the second column here. So it's going to go here, be A12. So first row, second column, again, 2 times 5 is 10, -3, and 0. So what is that? 7. Skip step here. Alright. Now I need another cell here, A21. So it's going to be second row from the first matrix to the first column. So second row, let me erase this. Second row, and then first column. Right? So again, I'm going to multiply -3 times 1. -3 times 1 is -3 plus -2 plus 8. Oh, I forgot the plus. So plus 8. So that's -5. That's become 3. I'll just put 3 here. Alright. Now the last cell is A22, which means the second row of the first column and the second row, the second row of the first matrix and the second column of the second matrix. So this one, A22, right? So we're gonna do that again. So I'm gonna have -15 plus 3 plus 0. Alright, so that's turned out to be -12. So I end up with 2 by 2. A11 is 4, A12 is 7, A21 is 3, and A22 is -12. Alright? Let's continue our chapter 9, matrix and determinant. So let me introduce you the identity matrix. Alright, identity matrix is an n by n matrix that the diagonal is 1 and anything below and above the diagonal is 0. So this is called identity matrix. You only have one at the diagonal. And the property of the identity matrix is that if you have any matrix multiplied by identity or identity multiplied by the matrix itself, you're going to get A back. Remember, multiplication in matrix is not commutative. So A times B may not equal to B times A. But if you multiply matrix to identity, you're going to get A back. Now, A minus 1 here is called the inverse matrix. So if you multiply A to its inverse, either to the left or to the right, you should get the identity back. And we're going to use this property to solve for unknown, which is x, y, or could be more than 2 variables. So let's make it simple by start from 2 by 2, all right? So I have this equation 5x minus 4y equal to 7, 4x minus 3y equal to 5. I put them in matrix. So my matrix A is the coefficient of this row. So 5, 4, or 5, negative 4, 4, negative 3. And my x here is the unknown. In this case, it's x and y. Sometimes you have more than one. You can have 5, 10, or infinite. But let's start from 2. And then the constant is 7 and 8. If you multiply it out, row times column, so 5x minus 4y would equal to 7. You get this one. If you multiply 4x minus 3y equal to 5. So you get this one. So it's really the same thing. So I need to explain how we're going to apply this inverse matrix to find the unknown. So I have matrix A times matrix X. Matrix X here is the unknown, could be 2, 3, 4, 5 variable, is equal to some B matrix. This is matrix. Alright, so next thing I'm gonna do, I'm gonna multiply by the inverse matrix to the left. So inverse of A to the left. If I do that to the left of A, on the left hand side of equal, then I have to do the same thing to the right hand side of an equal as well. Alright, so from this property here, you're gonna get I. Alright, you're gonna get I times matrix X, which is A inverse times B. Again, identity matrix times any matrix, you get that matrix back. So the unknown matrix here is going to be A inverse times B. So basically what I'm saying is that if you want to solve for the unknown matrix, you multiply this constant matrix by the inverse matrix of A, you will get the answer back. And we just do 2 by 2, but this apply to 3 by 3, 4 by 4, and so on. So my matrix, so I need to find the inverse matrix. For 2 by 2, that's the formula. If you have a matrix A, 2 by 2, that's the formula to get the inverse matrix. So let's look at our matrix A. This is our matrix A. So my A is 5, negative 4, 4, negative 3. Right? Then I need to find the A inverse. It's going to be 1 over A times D. So 5 times negative 3, that's negative 15. Minus B times C. So B times C. So negative 4 times 4 is negative 16. Alright? Now if this denominator equal to 0, you can continue, it's undefined. Right? So it's not 0 here. And then I will have A and D swap place. The A go here and the D go there. So my D is become negative 3. My A is 5. B and C is the same position but it's opposite side. So I'm going to have 4, negative 4. Alright. Now let's simplify. So my A inverse is going to be 1 over negative 15 plus 16, that's 1. And I have negative 3, 4, negative 4, and 5. So basically one time that matrix is just that matrix. So I'm going to solve for x and y in this case. So x is equal to A inverse times matrix B. So I'm going to have my unknown, which is my x matrix here. is going to equal to A inverse, which is this one, alright? -3, 4, -4, and 5. And then B, remember B, my B is my constant here. Okay, you need to multiply this. So let's look at this. I have 2 by 2, 2 row, 2 column, and I have 2 row, 1 column, right? So these two numbers are the same. Then if I multiply, I would have x would be 2 by 1. 2 by 1 is mean 2 row and 1 column. So you're gonna have A1, 2, right? So you're gonna multiply the first row to this column. Alright? So that's the first row and the first column. So that is -21 plus 20. Alright, then you're gonna multiply the second row to the first column, which is A21. So -28 plus 25. So far so good. So simplify this. You're gonna have -1 and -3. Remember you are unknown, or the x matrix is x and y. So your x is -1, your y is -3. If you have more than 2, then that's going to be x, y, z, and so on. So x is -1 and y is -3. That's the solution. That's where they cross. So let's check. All right, let's check here. I'm going to check here. If x is -1, I have -5. And if y is -3, I have +12, which is 7. The first one is correct. Let's check the second one. If x is -1, I have -4. If y is -3, I have +9, which is 5. Right? It's satisfied. Let's look at the next section. I'll see you later.